it must be recorded. Now I think it is record. Let me see. Okay, it's recorded. Let me see if you are able to see these slides. There are too many.
Yes, we see page 6.
I can see, hocam.
Yes, but I have opened it too much. I think I have to erase this. Let me check. Hold on a second. You know, in a limited time, I am trying to reduce the data in form that you are able to understand. I remove some calculations, some mathematical expressions to let you a little bit to facilitate your understanding. Because if I am going to add the all, then it will become too much complicated. And I try to summarize and introduce you the theoretical approach and then maybe if there is any extension, then we will introduce you probably later. Then let me check if you are able to see the slides. You are able to see the slides now?
Yes,
Is
yes,
okay?
Yes, okay.
Okay.
Yes,
Okay.
hocam,
Okay.
first slide.
Okay. Okay, as I said to you, quantile regression is the extension of the linear regression. It is used when the conditions of the linear regression not meet for the linearity, homoscedasticity, and the normality. And quantile regression is or has stronger distribution assumptions. When we supposed to be the null hypothesis is the no significance supposed to be realized between ln x, ln y, and ln z, or x, y, and z variables, then y is statistically significant if the p-value is less than 0.05, if there is an increase. Yes, please.
Hocam, the first slide has stuck. We couldn't see the second page. This is the covered page that we see at the moment.
Oh, okay. Then I have to quit probably from this presentation. Then it will be okay because I already quit. I stopped sharing. Then let me. Is it okay now? I think it's okay.
Yes, hocam.
Okay, quantile regression, as I said to you, but I have to enlarge it because there are some smaller sentences, smaller capital letters and small letters that I am not able to read it. As I said to you, if there is a p-value which is less than 0.05, then it's supposed to be statistically significant for y. And if there is an increase in 1% median value, let's say for y, then x will increase by 0.30% or 33%. And in the median value for z or ln z in not significant if it is greater than 0.05. The regression is a statistical method. As you are understanding, we are always using this regression for the all methods or the all tests. This is the very popular method for using and evaluating. And this is broadly used in the quantitative modeling and estimations. Multiple linear regression is a basic and standard approach in which researchers use the values of several variables to explain or predict the mean value of a scale outcome. However, in many circumstances, we are more interested in the median or an arbitrary quantile of the scale outcome. The quantile regression model is the relationship between a set of predictors, so-called the independent variables, and the specific percentile.
Excuse me.
Yes, please. Again, stop.
The second, this time, yes, second slide, quantile regression slide now we see, not the third one at the moment.
So I think I have to quit this large screen, then this will then okay.
It came now. It came now.
Okay.
Now we're at the fourth slide.
Okay, I have to. This is a problem.
I think it's now okay, hocam. Okay, hocam.
Okay, then what? For me, it's not okay. Okay. Okay. As I said, the quantile regression model, the relationship between a set of predictors, so-called independent variable, and the specific percentiles or quantiles of a target dependent variable, most often the median. It has two main advantages over ordinary least square regression. Quantile regression makes no assumptions about the distribution of the target variable, and quantile regression tends to resist the influence of the outlying observations. The quantile regression is widely used for researching in industries such as ecology, healthcare, and financial or in economics, which is popular that we are using in the EVU also.
Hocam, can I ask something?
Yes, please. Quantile regression.
Yes. Is Kuznets curve quantile regression? Kuznets curve between carbon dioxide and growth. Hello.
Yes, I think there is some disconnection. Kuznets curve, it is a inverse U shape. It is something different than the quantile. You are understanding. This is not the what we are doing for the standard deviation for estimating the unit root or for estimating the stability. The Kuznets curve is something as a theory which is applied largely in the economics, but you cannot directly combine to this quantile. Okay. Therefore, this is in economics, and it is also used in largely some estimations. It is somehow increasing, the inverse U-shaped, the Kuznets curve, and therefore it is somehow approach and related, but it is something else, not directly related to our issue. Okay, let me finish before creating any disconnection problem, because today I think the internet there is a problem. I don't know what is happening. Yes, quantile regression, the linear versus nonlinear model, why the quantile regression is going to be employed, and graphical representation is also questionable. The application is also a little bit different than the existence or experience this linear regression. And these practical examples, if we are able to do probably next semester, then you will understand how we are going to manage and realize and organize the data in the quantile application. The ordinary least square models focus on the mean, where it is, as you are understanding, y over x is y over x, or the conditional expectation function. Let's say applied economists increasingly want to know what is happening to an entire distribution, which can be achieved using quantile regression. The quantiles divided or partition the number of observations in a study into equally sized groups, such as quartiles division into 4 groups, quantiles division into 5 groups, deciles division into 10 groups, and centiles or percentiles division into 100 equal groups is subjected. For more, you can read the Gujarati, which is also in econometrics, very popular book. The linear regression used to relate the conditional mean to predictors, and quantile regression relates specific quantiles to predictors, particularly useful with non-normal date makes use of different loss function that ordinary least squares uses linear programming to estimate, as we are doing. Standard linear regression techniques summarize the average relationship between a set of regressors and the outcome variable based on the conditional mean function, and it provides only a partial view of the relationship, as we might be interested in describing the relationship at the different point in the conditional distribution of y, let's say, relation with the x and y. The quantile regression provides that capability, analogs the conditional mean function of linear regression. We may consider the relationship between the regressors and outcome using the conditional median function, let's say QD y over x, where the median is supposed to be 15 percentiles or quantile Q of the empirical distribution. The nonlinearity is a term used in statistics to describe a situation where there is not a straight line or direct relationship between an independent variable and a dependent variable. In a nonlinear relationship, changes in the output do not change in direct proportion to changes in any of the inputs, And nonlinearity is a mathematical term describing a situation where the relationship between an independent variable and a dependent variable is not predictable from a straight line. You know, this is very popular for estimating the nonlinear relationship in the equation. What is nonlinear model? In general, nonlinearity in regression model can be seen as nonlinearity of dependent variable or nonlinearity between independent variables, which is going to be introduced to you. The theory, how to detect the nonlinearity, of course, is questionable. The theory, in many sciences, we have theories about nonlinear relations with some phenomenon. For example, in economics, Laffer curves shows nonlinear relationship between taxation and the hypothetical resulting levels of government revenue. And scatter plots, when looking at the plot, you can see that the data points are not linear or not or nonlinear, sorry. How to detect nonlinearity? Seasonality in data in agriculture, building, especially, of course, the seasonality in agriculture very popular. Building industry, we often have seasonal data that we are going to employ and estimate the future prognosis or estimating the existing model. Especially in the agriculture, this is very popular because it is seasonal products and seasonal, let's say, marketing is subjected, and then you can easily employ and estimate. An estimated model does not fit the data well or does not fit it at all. The estimated P's, which is the coefficients, are not significant. This might suggest nonlinearity. As you are observing here, linear or nonlinear, it is given here. This is, of course, inverse relationship. On the left side is illustrated, and on the right side, so-called proportional relationship is illustrated between x and y. As you are observing, it is not perfectly linear or perfectly approaching to the line, but it is somehow on or somehow closer to the line which is going to be drawn at that dots which is given in this figures. As you see, the linear equation is given below. Y is equal to b plus b. X is the linear equation, and when you are making the b1 minus, then this will be the for left graph equation, or the slope will be illustrated as an inversely related. And for the right one, you can consider the equation which is given below. And when we are approaching and observing this nonlinearity as it is illustrated here, it is not a straight line anymore. And the equation is somehow given as you observe in the log form. The linear or nonlinear again is given. Now it is increasing function and we have the power of 2. This is an indication that we have nonlinear estimation. Then you can consider for this model. And if it is given in this type, which we don't use usually, then you will then employ and illustrate and estimate the future prognosis. This is also given in the U shape in inverse form and in the U form, where the equation is given below, but is of course not directly related with the graphs, but it's just given to you to for being able to understand how it is going to be represented. Quantile regression allows us to study the impact of the independent variable on different quantiles of dependent variables distribution. It provides a complete picture of the relationship between x and y, or y and x, robust to outliers in y observation, estimation, and inference, distribution free, analysis of distribution rather than average, and quantile regression allows for effects of the independent variable to differ over the quantiles. The introduction, first proposed by Koenke and Bassett, quantile regression is an extension of the classical least square estimation, as I said to you, and OLS. Regression only enables researchers to approximate the conditional mean and media located at the center of the distribution. And quantile regression is applied when an estimate of the various quantile in a population is desired. The classical linear regression estimates the mean response of the dependent variable and dependent on the independent variables, and there are many cases such as skewed data, multimodal data, or data with outliers. when the behavior at the conditional mean fails to fully capture the patterns in the data. The outliers, if you are questioning what is it, in regression are observations that fall far from the core points. These points are especially important because they can have a strong influence on the least square lines. If the absolute value of any residual is greater than or equal to 2 standard deviation, then the corresponding point is an outlier. If you flash back to the former, let's say, classes or lectures, the standard deviation, or the so-called S, is a measure of the spread of data about the average, and we don't care which direction of these differences is. So we will be ignoring the sign of the differences, and in other words, the standard deviation is the square root of oh my goodness. I think there is a problem with the I don't know. Are you able to see the slides? Should I have to continue?
We were gone for a couple of minutes, so Jam, now we are all right.
I don't know. There is problem today, probably from the server. Continuously something happens. The equation that we have done as the root square of this summation of the x minus xt total, it is the power of 2, is divided to n minus 1, is the variation, this square root of the variation. This is the standard deviation, which is going to be illustrated in the first or the second lecture. This is also a little bit problematic. Okay, if any point, as you see, the graph here is given. If any point is above y2 or below y3, then the point is considered to be an outlier, as you see here. Use the residual and compare their absolute values to standard deviation, which is multiplied 2, where S is the standard deviation of the residual. If the absolute value of any residual is greater than or equal to 2 standard deviation, then the corresponding point is an outlier, as it is represented here. It is a little bit far from the expected line, or the line that we are drawing to this, let's say, not perfectly linear graph that we illustrated here. It is a little bit somehow is away from the expected estimation. Common regression methods measures differences in outcome variable between population at the mean, which means ordinary square regression, or a population average effect after adjustment for other explanatory variables of interest. And quantile regression method is more robust to the outlier. And these are often done assuming that the regression coefficients are constant across the population. In other words, the relationship between the outcomes of interest and the explanatory variables remain the same across different values of the variables. The distribution of y, the dependent variable so-called, conditional on the covariate x, may have thick tails. The conditional distribution of y may be asymmetric, and regression will not give us robust results. Outliers are problematic, then mean is pulled toward to the skewed tail. OLS are sensitive to the presence of outliers. An outlier is an observation point that is distant from other observations. An outlier can cause serious problems in statistical analysis, and the impact of income on consumption, let's say, is conditional on mean. It may give misleading results. If conditional on different quantiles, it will capture outlier in consumption, look like in Ramadan, the consumption is increased, or in the Christmas period of time, or in Chinese New Year period of time, the consumption and the shopping period will become boomful. As you know, in the Black Friday period, they have some reduction on the prices, but the market is somehow enlarged and increased. While the quantile regression estimator minimizes the weighted sum of absolute residual rather than the sum of squared residuals, and thus the estimated coefficients vector is not sensitive to outliers. The quantile regression approach can thus obtain a much more complete view of the effects of explanatory variables on the dependent variable. And when they employ quantile regression, Histogram, not normal distribution, as I mentioned to you. It is expected or desired, and p-value is less than 0.05. As you know, in the OLS, it is opposite. And LM is the p-value is expected to, again, less than 0.05, and heteroscedasticity, again, is less than 0.05 is expected, which is not expected in OLS. As in OLS, the histogram normal distribution is desired to p-value more than 0.05. LM results or no serial correlation is expected. The p-value must be, again, more than 0.05, and heteroscedasticity, again, more than 0.05 is expected. Therefore, this is the must to being able to employ quantile regression, which is rarely observed. I use once in my, let's say, research quantile, because when you employ the data, mostly they are mixed, and this is the very, very rarely observed. This histogram and LM and his heteroscedasticity rarely becomes smaller, and this is then somehow dependent to the estimation and data that you are using. Therefore, quantile regression is very important to consider this, let's say, assumptions. Reasons to the use quantile rather than means: analysis of distribution rather than average, robustness, skewed data, interested in representative value, and interested in tails of distribution and unequal variation of samples. If income distribution is highly skewed, which means high, low, and middle, then mean based coefficient cannot capture the accurate distribution of the income. The comparison, when we are going to make again between the quantitative, let's say, a statistical model that utilize one quantitative independent variable x to predictive quantitative dependent variable y, the linearity, the y variable is linearly related to the value of the x variable, independent of error. The error residual is independent for each value of x, and homoscedasticity, the variation around the line of regression, be constant for all values of the x, and normality, the values of y, be normally distributed at each value of x. That's why I said it is very rarely observed and employed regarding to this assumption. What are the assumptions? Once again, the regression has 5 key assumptions, as I said to you: linear relationship, multivariate normality, no or little multicollinearity, no autocorrelation, and homoscedasticity is expected. The best OLS, when we are flashback again to the regression analysis, the L-square value must be high. It should be at least 60% and more than 60% for being able to have a good model. And no serial correlation. LM test results probability value must be higher than 0.05. No heteroscedasticity in the residual p-value must be higher than 0.05, and the residual supposed to be normally distributed. The histogram p-value must be higher than 0.05. And when should I use quantile regression? Quantile regression is an extension of linear regression, as I said to you, when the conditions of linear regression are not met: linearity, homoscedasticity, independency, and normality. That's why I'm repeating and trying to make it more clear. And best quantile regression then is questioned. Then HO, so-called the null hypothesis, residuals are serially correlated, and H1, the alternative hypothesis, residuals are serially correlated. The L-square value is not relevant for the quantile regression. Variability explained as measured in terms of variance in any way, as let's say, is essential at least square concept, but important is to find what is an appropriate measure of statistical significance or possibly goodness of fit among variables is more than this L-square value, which is the relationship, so-called the impact of the each other's or concept models to each other is more than the S-square. The serial correlation LM test probability value must be less than 0.05. The heteroscedasticity again less than 0.55, and the p-value again for the normality for the residual less than is expected less than 0.05 is expected to be realized for maintaining performing this or employing this method. Quantile regression R-square value, meaning the goodness of the fit of quantile regression, the pseudo or spurious R-square value is assumed to be, let's say, 29%, and the adjusted S-square value is 27%. So the 27% variation in the conditional median in ln x is due to ln y. In the quasi-least square statistic value, when we are observing this R square and adjusted R square, it is indicating that the model is stable and more reliable, so-called. But in the quantile, it is somehow, as you are observing, the relationship, then how it is fixing and affecting each other. An advantage of the quantile regression, while OLS can be inefficient if the errors are non-normal, and quantile regression is more robust to non-normal errors and outliers. And quantile regression also provides a richer characterization of the data, allowing the researchers to consider the impact of a covariate on the entire distribution of Y, not merely its conditions mean. How to perform it? The first, estimate the quantile regression for, let's say, 50 quantile, the median, the estimation of quantile regression for the 25, let's say the first quartile, and the 75, the quantile, the third quartile simultaneously. Compare the quantile regression estimated in, let's say, 2 with the OLS regression. One possible reason that the coefficients may differ across quantiles is the presence of the heteroscedastic errors. The estimated quantile coefficients may look different for different quantiles. To see if they are statistically different, we use the Wald test, as you are remembering, for the many vector error and others. We can use the Wald test to test the coefficients of a single regressor across the quantiles, or we can use it to test the equality of the coefficients of all the regressors across the various quantiles. You can look again the Gujarati for further readings. This is then the representation of this quantile. As you are observing, when you are having this linear equation here, the quantiles and the outliers is a little bit far from the expected linear equation. And this is then the representation or the relationship between the income and expenditure. As you know, as much as income is the function of the, in Keynesian economics, the income, or so-called disposable income, is the function and of the expenditure, also called the governmental expenditure, is the components of the output or the Y. Therefore, it is expected to parallelly increase as much as your income is increased, disposable income is enlarged. We are expecting that the expenditures, the governmental expenditure or your expenditure, your consumptions is enlarged and increased. But somehow, as you are observing here, as much as your income is enlarged and increased, this outliers becomes a little bit approach to the higher level. And when you are drawing this line, some part of these expenditures becoming a little bit lower and some is becoming to the upper. And when you go further to the enlarge and increase, the expenditure becomes enlarge and increase, which is not really perfectly illustrated here. But this is because of the expectation of the people and some other reasons, saving purposes and some other marginal propensity of saving and consumption is affecting and changing this, let's say, graph. Here is also illustrated the, as you see, the shape of the interest margin is leptokurtic, which is not captured by normal distribution based models. The mean is pulled toward the skewed tail. As you are observing, it is very high and very, let's say, skewed and very, not very flatter. It is very sharp, let's say, U shape is illustrated here. Therefore, this is then the realized the mean is become a little bit pulled toward to the skewed tail, as you're observing on the graph. And the quantile regression model is given also here, the OLS, which is we minimize the sum of the scarce errors. As you are observing here, the U is equal to Y minus BX in the bracket square. And the quantile regression then is the absolute value is given in below. The absolute error is equal to absolute Y minus B minus, which is then represented in the linear equation form. The quantile regression supposes a sample of n pair of observation x, I, and yi is given in a, let's say, time series. I is then 1, 2, let's go to n. We are taken from population distribution. A population quantile regression model can be written as yi is equal to bq0 plus bq1 xi plus it goes like this, and I is then goes to n, where bq0 and bq1 goes to the n, and unknown population parameters associated with the q power of, let's say, the quantile, and the error term associated with the quantile, such as between 0 and 1 is expected. Suppose bq0 and bq1 are the estimates of the corresponding parameters, and these can be obtained after minimizing the absolute sum of errors if it is employing this error term in the equation. Here, the b is the estimated rate of change in specific quantile, q in a response variable, where it is y for 1 unit change in predictor will then affect variable x. And this is then, of course, in the equation will be illustrated and presented, and in the conclusion how it is affecting and changing the parameters each other. And b as a parameter or coefficient is the estimated specific quartile, q of the response variable y, where predictor variable x is supposed to be 0. Hence, the estimated simple linear quantile regression model is then y is equal to b0 plus b1. X can be represented or illustrated in the model. If you are going to estimate b and q, then you may then say b is the, let's say, 50% or 30%, then is the 1 unit of change on y will then affect, sorry, x will affect then y, let's say 40% or 50%, which is considerably high. As the classical linear regression which means OLS estimator only focuses on the mean value, where quantile regression defines the data in a better way, as it analyzes the level of interest margin by quantiles, as mentioned before. Thus, the quantile regression is an extension of the classical regression model, as I mentioned to you, to estimate the conditional quantile functions, and quantile regression is super over other usual mean value regressions, as it allows for the analysis of different levels of thresholds of dependent variable, if you are going to use, of course. Actually, quantile regression should be in two sections. This was the theoretical presentations, then we could do the application also, but unfortunately, for this semester, it is not necessarily introduced to you, because I suppose some theoretical information and some let's say, as I try to, as much as possible, to give you the theoretical approach of this quantitative application, because economics or financial or business is not the calculation, but it is only the interpretation. It is the mean how we are going to interpret your data, whether you are able to estimate really correctly regarding to these models and regarding to the theoretical basis, and then you will then interpret your presentation and make some suggestions and prognosis for the future, or for the estimating existing model for your economy or for your business or your institution. I hope I try to, as much as possible, to summarize and try to fruitful to you in a short period of time. Unfortunately, sometimes we had some, let's say, conflicts and some misunderstanding to each other. But I am trying to give you the correct estimation. Sometimes misleading and misunderstanding between each other can be happen. But I try to give you at least the theoretical part and the applications as much as possible in the way which is going to be done in generally in the, let's say, our departments, our economics business departments, or in the sector. If you have any question, then I'm ready to help you in the future. Also, you can contact me anytime. I can help you and support you. Our exam, I have to say, I will give you some questions, some, let's say, theoretical application. I quit these estimations or any, because we have to do this in, let's say, a program. And if I'm going to give you, for example, some example to do, this will then require a longer period of time Therefore, I try to give you a quicker question for being able to understand whether you get the necessary information and antidote for this course, and then you can put on it for your future estimations. As I said to you, I try to become fruitful for you, and if you have any question, I am ready to help you. And if you are having any question, then please do not hesitate to ask me. If not, then I will quit because I have another presentation in a minute. Do you have any question?
Hocam,
Yes, please.
for the final exam, how is going to be the before midterm and after midterm parts? We are responsible with both of them, or only piece of it, or how is it weighted?
Well, if I am going to exclude midterm or until midterm, then it means you don't have to study the regression or some other, let's say, unit root and some standard deviations, mean, media, these things, which is also, as you see in our classes, in our lessons and lectures, we are using this. And it is better that you study this. For me, is important your study, you hardworking effort. If you study and you try to interpret your knowledge as much as possible in a way that you are understanding, for me is enough. I am not forcing you to study the midterm. If you know everything, then you can study second part. But I suppose you study all because some students need some more improvements, and it is necessary to study the whole concept because this should be in a book. You have to look the Gujarati or some others, Marala and some other people's econometrics professors' books for helping hand, because we are using these books, and I don't offer any classical teaching. Unfortunately, we have online classes, and because of this EU also applications. Therefore, you read the material that I uploaded. This will be a very helping and briefly introduce to you most things. And if you have any problem, then you can ask me. As I said to you, it is mostly the theory and application together, of course, how it is employed and applied to the system, to the EU, also is introduced to you in a short period of time. At least then you will then able to understand the way, and then you will develop on it your knowledge if you study hard. Therefore, it is not possible to exclude the midterm or before midterm. You have to study whole stuff. It's not too much, I think, because you are PhD student and you have to learn to study too much. And you are the one who are study very hard. And Taptik also, Zirkula, I don't know, İlkem and Ahmed never met in this direction. But you should study hard, then you will do your best, I know. You don't have to worry about it. I am supporting students who are studying. And as I said to you, your assignments is also in my consideration, whether you did perfectly or not. I am always giving the full points because this is your efforts and this is your progress. But you have to show your also intention. Okay?
Thank you, sir.
Do you have any question? If you don't have, then I have to quit because I have one more small short presentation for the other class. Okay, thank you very much for you joining. See you in the exam. We have the exam on 19, isn't it, Hussein? We have 19.
I think so, hocam.
19, isn't it? 19 at 1 o'clock. I have to inform you. You have to inform your colleagues also. We will publish it. I think Hussein will publish this.
It's published. It's published in the queue. I'm not very sure about the timing.
I think it was 1. We did determine at 1, I think.
It should be either 12, 12:30, or 1:30, hocam, because it goes in half hour.
It doesn't matter. If you want later, then I can. It depends to you whenever you want.
On the queues, when it's announced, the announcement time is always either 12:30 or 1:30, because we don't have full hours. We always
okay.
Go
then 1:30 is better. I think it's the best time. I think. Okay, 1:30 is better. Okay, then I wish you success. as I said, I will definitely support, but you study also hard, because this is the one of the important part of your PhD, and you have to learn carefully. And regarding to this knowledge, if I don't know if I am going to give you any economics lesson, I am economics professor, not the econometric professor. I have to inform you this also. And if you get any economics classes or any this business classes, managerial economics or something, or any macro micro, this will then becomes more, let's say, combined. You will then better understand to combine and write everything very comprehensively, because only quantitative application is the part of this, but the representation of your data for your papers, for your academic career is also important. Okay, then see you then next week, I think, or after the next week. The day we have some 15 days, I think, isn't it? Oh,
Yes,
Yes, sir.
hocam. Thank you.
okay, then see you then.
Thank
to the
you so
exam.
much, sir.
Thank
Bye
you. Bye-bye.
bye.
Bye bye.
Bye bye.
Bye, sir.
Bye bye.